Welcome to the debate. If you are listening to this right now, maybe while commuting in a heated car or sitting in a nice climate-controlled room, I want you to try and conceptualize something that our modern lives completely shield us from. I want you to imagine negative 40 degrees Fahrenheit.
Yeah, that is practically impossible for most of us to actually feel or understand.
It really is, because we have this pervasive, almost comical pop culture image of human survival in extreme ancient environments. We picture shivering cave people wrapped up in crude, ill-fitting furs.
The classic image of them huddled miserably around a sputtering little fire.
Exactly. Essentially just enduring the night and praying they don't freeze to death. But that image completely shatters when you look at the reality of the Eurasian steppe during the last ice age. At negative 40 degrees, the wind does not just chill you, it actively hunts you.
Right. It is an immediate, acute physical trauma to the human body. There is no biological adaptation that saves a naked ape at negative 40 degrees. Every inhalation actually causes microscopic damage to your lungs.
Yeah, exposed skin begins to die, literally undergo necrosis, within minutes. The moisture in your own breath freezes on your eyelashes and inside your nostrils. A modern human dropped into that environment without extensive preparation would not just be uncomfortable, they would be completely dead before sunrise.
The cold is a predatory force, and the margin for error is absolute zero.
Which makes it all the more astounding that our ancestors didn't just endure this landscape. They thrived in it for hundreds of thousands of years. And, well, that brings us to the fascinating core of today's discussion. Right now, modern military Arctic training programs, along with elite international disaster relief organizations, are actively teaching and utilizing shelter-building methods derived directly from 20,000-year-old archaeological reconstructions of Paleolithic designs.
Which is wild to think about. 21st century engineers are looking backward, lifting these ancient structural blueprints and deploying them to save lives in modern extreme environments.
It is. It forces a complete reevaluation of what we consider primitive technology. But it also raises a profound intellectual question, which is the specific tension we are exploring today. When these modern military and disaster relief organizations adapt these Paleolithic survival techniques, what exactly are they doing? I argue that these adaptations prove these ancient structures were perfected modular engineering solutions based on universal physics that cleanly transcend their original context.
And, well, I counter that extracting just the architectural techniques completely ignores the fact that ancient survival was a continuous, comprehensive operating system. It blended structural maintenance, highly calculated chemical fuel processing, and even biological sleep adaptations, meaning modern applications are merely a functional mimicry, not a true replication of the ancient technology.
Let's get right into the mechanics of this then, because I want to look at the sheer structural brilliance of what they were building. Our Ice Age ancestors were engaging in deliberate, highly sophisticated thermal engineering.
They absolutely were.
If you look at the evidence from Dolní Věstonice in the Czech Republic, dating back roughly 26,000 years, the winter shelters there were not just random piles of mammoth bones and dirt. They featured walls built from multiple, highly specific layers, and each layer served an isolated, precise thermodynamic function.
The stratification of those walls is a masterclass in material science, using only biological matter.
Let's break down how it actually worked, because it mimics modern building science perfectly. So the innermost layer was animal hide hung with the fur facing inward. The physics here are simple but critical. Thousands of individual hairs trap a microscopic layer of stagnant air directly against the bodies and the radiant heat source inside.
Right, it's essentially a prehistoric radiant barrier.
Exactly. But then, outside of that hide, you have a middle layer composed of densely packed dried grass and moss.
Which serves as the desiccant.
Right. Because when humans breathe, and when they cook, they release a massive amount of water vapor into the air. In a sub-zero environment, if that vapor hits a cold, solid wall, it instantly condenses and turns to ice.
And if your insulation freezes solid, it loses all its thermal retaining properties. The cold transfers right through.
Exactly. The physics are ruthless. So the dried grass wicks that moisture away from the interior space. And then, finally, the outermost layer consisted of tightly woven mats of reed and bark. This acts as a windbreaker to stop the sheer kinetic force of the freezing air. But, and this is the genius part, it was semi-permeable. It was breathable.
So it allowed the wicked moisture from the moss to physically escape the structure before it could freeze and destroy the wall from the inside. It is a functional vapor barrier, predating industrial synthetic wraps by tens of thousands of years.
So this is my fundamental point. The physics of insulation, moisture control, and weatherproofing are universal constants. The mathematical equation for trapping heat and expelling moisture does not change depending on what century you live in.
Sure, the math doesn't change.
Because these thermodynamic principles are universally true. Modern disaster relief groups can look at Dolní Věstonice, cleanly extract those exact layered principles, and apply them. The materials are different today. I mean, a military unit might deploy synthetic closed-cell foams and woven Tyvek wrap instead of moss and bark. But the thermodynamic math is flawless and universally applicable. They are deploying a modular blueprint.
Okay, I have to jump in here. You are describing a static object. You are talking about a tent as if it is an artifact you can set up, zip closed, and just walk away from.
Well, no, not walk away from entirely.
I fundamentally reject the premise that this shelter can be cleanly separated from the continuous physical behavior of the humans operating it. The text we are analyzing makes it incredibly clear that these structures were not static products. They were a living system that the inhabitants managed continuously.
I mean, a modern house requires maintenance too. You have to clean the gutters, you have to replace the roof every 20 years. No structure is completely static.
But the biological cost of that maintenance is entirely different. Archaeological evidence from these sites shows intensive, ongoing, daily winter maintenance. You have to remember what these materials actually are. They are decaying biological matter.
Right, which degrades.
Exactly. Hide coverings tear under the stress of gale force winds. Moss insulation compresses and loses its thermal value, or it occasionally freezes if the interior fire drops in temperature for even an hour. The bones used as structural supports crack under the sheer weight of snow.
But that's just structural upkeep.
It's more than upkeep. It's an unbroken behavioral loop. The inhabitants were constantly patching, replacing, and adjusting the envelope of the shelter. Modern military and disaster applications treat survival engineering as a product to be deployed from a helicopter. The Paleolithic approach, you simply cannot separate the physical layers of the wall from the constant, grueling physical labor required to keep those walls from rotting or collapsing. The shelter was an organ, and the intensive human labor was the metabolism keeping it alive.
I hear that, but I think you are conflating the durability of the materials with the validity of the engineering concept. Let's scale up and look at the macro architecture, starting with the subterranean structures.
Okay, let's look at the macro.
If we go back 800,000 years to Castro in Russia, we see early humans deliberately excavating massive circular depressions into the earth. I'm talking 6 to 8 feet deep, 12 feet across.
Which is an unimaginably brutal task when you consider the ground they were digging into.
Exactly. Think about the sheer caloric cost. They are digging through hardened, often frozen earth, using what? Antlers? Pointed rocks? It is a staggering expenditure of human energy. But they did it because the physical payoff was universally sound.
Because getting below the frost line is everything.
Right. At 68 feet below the surface, the ground temperature stabilizes. Even if the air above is -40, the earth down there might be 20 or 30 degrees warmer. It's the same reason a modern basement stays cool in the summer and warmer in the winter.
It is geothermal insulation. By getting into the Earth's crust, they are neutralizing the wind chill entirely.
Yes, and then as human engineering progresses, we see the mammoth bone houses found at sites in Ukraine and Russia, like Mezhorich and Kostenki. Here, they took that thermal ambition above ground.
The bone houses are incredible.
We are talking about utilizing 200-pound mammoth skulls as foundation anchors. They took curved mammoth tusks and intricately interlocked them to form complex, load-bearing domes. These structures were capable of maintaining interior temperatures 40 to 50 degrees warmer than the outside air.
Just through geometry and mass.
Exactly. The sheer geometry of a dome is perfectly designed to shed heavy snow loads and deflect high-velocity winds without creating structural drag. This functions identically to modern passive heating architecture. When military Arctic programs deploy dome-shaped, double-walled synthetic tents, they are doing it because the ancients solved the math of the dome and the physics of passive heat retention. It is a blueprint.
Wait, let me stop you there, because you keep using words like modular and blueprint. That implies a plug-and-play adaptability that completely ignores the logistical reality of the Ice Age.
How so? The geometry is the same.
Let's look at what it actually takes to build a mammoth bone house. Building one of those structures required 2 to 3 weeks of intensive, continuous labor by a highly coordinated group of 8 to 10 adults. And more importantly, you couldn't just throw up a mammoth bone house when the first blizzard hit. It required meticulous seasonal planning. You had to start construction in late summer or early autumn.
Well, obviously, the procurement of mammoth bones is a slower supply chain than pulling a nylon tent out of a military duffel bag.
But it is not just about the speed of procurement. It is about the entire operational paradigm. Modern disaster relief, by its very definition, is reactive. An earthquake destroys a city, a sudden blizzard strands a unit, and you drop in emergency shelters.
Right.
The ancient survival method was fundamentally proactive. It required highly complex ecological calendars running continuously in the builders' heads. They had to track animal migration patterns to know when the bones would be available. They had to know exactly when the ground would freeze so they could dig the foundations before the earth turned to concrete.
They were highly attuned to the biome, yes?
Exactly. They had to calculate daylight hours. When a modern military unit swaps a 3-week mammoth bone gathering expedition for a 2-hour deployment of synthetic aluminum pole equivalents, they aren't just changing the material. They are ripping the physical shape out of a deeply rooted ecological synchronicity. You can't pack a mental generational calendar into a military duffel bag.
I'm struggling to see how the timescale of the construction invalidates the underlying engineering principle, though. Let's look at the actual physics at play.
Okay.
The geometric principle of using curved, interlocking, high-density materials to shed snow and block wind remains objectively valid. If I hand you a blueprint for a bridge, and it takes you 10 years to build it out of stone, but I build it in 10 days out of prefabricated steel, the engineering blueprint of the arch is still what's keeping both bridges standing.
But a stone bridge and a steel bridge resonate differently under stress.
Sure, but the math of the arch holds. The fact that a modern military unit can execute the deployment of a thermal dome in 2 hours instead of 3 weeks only highlights the purity of the geometric concept. The math of the dome simply doesn't care if it took you an hour or a month to assemble it. The structural integrity holds either way.
But a dome made of modern carbon fiber behaves entirely differently under thermal stress than a dome made of dense, porous bone and ivory, surrounded by massive amounts of decaying biological matter. If you extract the shape but change the mass, you change how the whole space functions.
Trapping heat with perfect insulation actually creates a lethal problem, regardless of the material. If the walls are perfectly airtight, you've just created a death trap. You light a fire in a sealed, heavily insulated dome, and the inhabitants will be dead from carbon monoxide poisoning within an hour.
Or the moisture from their breath will freeze the interior solid.
Right. So how do they breathe? How do they not suffocate without letting the negative 40-degree air back in?
Which brings us directly to the internal mechanics. Moving from the external skeleton of the shelter to how heat and airflow were actively managed. This links the structure inextricably to the element of fire. And the text we are drawing from is explicitly clear on this point. Fire was not just a heat source. It was the entire operating system of Ice Age winter life.
It was the engine of the house.
It was, but an engine requires highly specific engineered fuel. I want the listener to really think about this for a second. If you go into your kitchen right now, take a raw cow femur, put it on your stove, and try to light it on fire, what happens?
It doesn't catch.
Exactly. It chars, it smokes, it smells absolutely terrible, but it does not sustain a flame. The Eurasian steppe during the Ice Age was largely treeless. There was no abundant wood to gather. So what did they do? They engineered fuel out of the biome.
They rendered bone.
They developed a process to render and burn bone, which requires a massive ignition temperature. They collected mammoth dung, dried it to exact specifications, and treated it like a calculated, predictable chemical energy resource. Chemical analysis of ancient hearth residues shows this fuel was deliberately processed for specific, long-lasting heat outputs.
Which is incredible chemistry. Bone marrow acts almost like a slow-release thermal battery once you finally get it hot enough to ignite.
It's an engineered chemical process, but modern disaster relief tents, while they may copy the ancient dome shape, rely entirely on external industrialized fuel supply chains. They use propane heaters, kerosene generators.
Yeah, they bring their own heat.
Right. The ancient system was entirely self-contained. It was biologically integrated and chemically engineered from the immediate local environment. If your supply chain breaks today, the modern tent freezes. The ancient system literally was the supply chain.
I am not denying that their fuel chemistry was a masterpiece of survival, but I think you are glossing over the structural genius that actually allowed that bonfire to exist safely inside the dome. Let's look closely at the ventilation systems, particularly those excavated at Kostenki.
The convection systems, yeah.
As we established, if you seal yourself in, you face carbon monoxide and lethal humidity. At Kostenki, archaeologists didn't just find holes poked in the roof, they found precisely engineered airflow systems. They built small intake openings positioned carefully near ground level.
To pull in the cold air.
Right. These were designed to pull in dense, cold, fresh air from the outside. Then, they constructed larger exhaust openings near the apex of the dome.
Utilizing the fluid dynamics of convection.
Yes. As the fire heats the air, it becomes less dense and rises, carrying the carbon monoxide and the heavy water vapor from human breath up and out of the apex hole. This rising column of hot air creates a vacuum at the bottom, which actively pulls the fresh oxygen in through the lower vents to feed the fire and the humans.
It's essentially a prehistoric chimney effect.
They literally mapped and manipulated convective currents. This specific, highly calculated airflow management is the exact feature that modern Arctic engineers look at and are genuinely stunned by. When military designers build sub-zero tents today, they use this exact placement of intake and exhaust vents to solve the universal human problem of breath moisture freezing on the inside of the fabric. They isolated the problem of humidity in a freezing environment, and they engineered a structural solution that we literally still manufacture today.
I have to stop you because I just do not buy that the ventilation is a modular, easily extractable feature. You're treating it like a universal slider you can just adjust on any tent.
Why isn't it? Airflow is airflow.
Because the ventilation at Kostenki wasn't just a general concept. It was a deeply tuned system. The size, angle, and placement of those vents perfectly matched the specific heat output of their highly engineered dung and bone fires. It was in total equilibrium.
Well, yes, they built it for their specific fires.
And furthermore, it was tuned to their precise spatial zoning. The text notes that these structures contained primary, central hearths meant for deep, radiant heating of the whole structure, but they also had smaller, secondary hearths positioned strategically for specific tasks.
Like tool making over here, a slightly warmer zone for nursing infants over there.
Exactly. The draft created by the lower vents and the exhaust at the apex were in a delicate, calculated physical equilibrium with the exact thermal mass of those specific, meticulously managed fires.
But convection is a self-regulating physical process, though. Warmer air rises faster. It scales.
To a degree, yes. But think about what happens when you introduce modern technology. If you drop a modern high-output propane heater into a similarly vented modern structure, you fundamentally disrupt that careful ancient equilibrium.
Because of the combustion byproducts?
Precisely. Burning propane introduces massive amounts of water vapor into the air as a chemical byproduct of combustion, far more water vapor than a smoldering mammoth bone fire produces. The ancient ventilation was perfectly calibrated to their specific dry fuel chemistry and their behavioral zoning.
Okay, I see where you're going.
Right. If you extract the geometric vent design but change the heat source to propane, you are completely mismatching components. The vents won't clear the propane moisture fast enough, and the modern tent will ice over from the inside.
That is a fair point about the byproduct of propane. I'll concede that. The chemistry of combustion does change the humidity load. You have to scale the exhaust. But I still argue that the fundamental mechanism, the strategic placement of intake and exhaust to manage thermal gradients and expel moisture, is an extracted principle that objectively works.
Even if you have to change the dimensions?
Yes, we just adjust the diameter of the modern vents to accommodate the increased moisture output of the propane. The geometric blueprint remains the absolute foundation of the modern design.
But the foundation of ancient survival wasn't just physical geometry. If we expand our view from the shelter itself to the biological patterns of the human beings operating inside it, we hit the ultimate limit of this modern adaptation argument. The shelter literally cannot be decoupled from human biology.
You're referring to the sleep cycles the text brings up?
I am. And this is crucial. The text highlights a fascinating vital component of this survival system, the biphasic sleep pattern. For hundreds of thousands of years, humans did not sleep for 8 uninterrupted hours like we attempt to do in the modern era.
Right, they slept in shifts, essentially.
They slept in 2 distinct phases. They would go to sleep for about 4 hours, then experience a mandatory wakeful period of 1 to 2 hours in the middle of the night, followed by a second 4-hour sleep phase.
Which isn't just an anthropological guess. It's a documented biological default.
Precisely. The psychiatrist Thomas Ware proved this in a landmark 1992 experiment. When you take modern humans and strip away artificial lighting, plunging them into extended darkness, their brains automatically revert to this 2-phase sleep pattern.
It's hardwired into us.
Now, why does this biological quirk matter for the architecture of the shelter? Because a smoldering bone and dung fire in a mammoth shelter requires active tending. It does not burn evenly all night on its own. If everyone in that shelter sleeps for 8 consecutive hours, the fire dies, the interior temperature plummets, the vapor barrier freezes, and at -40 degrees, everyone is dead before morning.
Wow. So the biology ensures the fire survives.
Yes, the biphasic sleep biology functionally guaranteed that there were awake, alert humans tending the thermal core of the shelter in the dead of the night.
It is an incredible alignment of human physiology and environmental necessity.
And it goes far beyond just stoking the flames. Anthropologist Polly Weissner conducted research on contemporary groups living close to this original pattern. Her data shows that 81% of nighttime firelight conversation was devoted to stories, myths, and social binding.
So they weren't just sitting around in silence.
No, this period of mandatory wakefulness wasn't spent talking about the logistics of the next day's hunt. This was the crucible of human culture. This 2 a.m. wakefulness in the winter shelters directly facilitated the creation of complex cave paintings and the carving of Venus figurines. The physical shelter absolutely required this specific biological rhythm to survive the night. Modern military training obviously does not enforce biphasic sleep, nor do soldiers sit up at 2 a.m. carving ivory mythologies to keep the tent warm. Therefore, they are only copying a tiny physical fraction of the actual survival strategy.
Let me jump in here because I think you're fundamentally conflating the logistical necessity of a task with the cultural byproduct of that task. Let me offer a parallel analogy to explain what I mean.
Okay, go ahead.
When modern civil engineers study and adapt ancient Roman aqueduct designs for contemporary water management, utilizing the exact same principles of gravity, slight descending gradients, and arched load-bearing supports, we don't need to adopt the Roman pantheon of gods.
Well, obviously not.
Right, we don't need to speak Latin, and we don't need to wear togas for the water to flow down the pipe. The water flows because the physics of the aqueduct are objectively sound.
But a water pipe doesn't require a human being to stay awake and actively participate to keep gravity functioning.
True, but the necessity of tending the fire is simply a logistical problem of fuel feed. Modern technology solves that exact problem with automation. The fact that the Paleolithic thermal layers and the complex ventilation systems can be decoupled from biphasic sleep, decoupled from mammoth bone procurement, and decoupled from Paleolithic art, yet still successfully save lives in modern disaster zones, is the ultimate proof of their engineering purity.
I think that's a very mechanical way to look at human survival.
But it's accurate. The modern disaster relief worker or soldier has a continuous fuel source. They have a propane heater connected to a thermostat. They do not need to wake up at 2 a.m. to physically stoke a bonfire because the machine does the feeding. But the fabric tent surrounding them is still insulating them using the exact thermodynamic layering principles developed 26,000 years ago. We haven't stripped away the genius. We have simply automated the physical labor out of the system, leaving the pure, unadulterated engineering behind.
You call it automating the labor. I call it severing the profound, necessary relationship between the human being and the environment. You are arguing that the architecture is the technology. I am arguing that the human behavior, the relentless vigilance, the specific fuel foraging, the synchronized sleep was the actual technology, and the architecture was merely its physical manifestation.
Let me broaden the scope of the evidence to support the modularity of their engineering, because this genius wasn't restricted just to the walls of the house. Look at the composite principle they applied to their clothing.
The layered hides?
Yes, it operated on the exact same thermodynamic logic, entirely separate from the shelter. They didn't just drape a single heavy pelt over their shoulders. They designed multiple layers of different animal hides, specifically selected for highly distinct thermal properties.
Right, utilizing the different densities of fur.
Exactly. You would have wolf fur or Arctic hair on the innermost layer, tailored to trap the warm air against the skin. Then you would have specialized, smooth, wind-shitting layers on the outside, specifically treated to repel moisture. They essentially conceptualized and fabricated Gore-Tex 25,000 years before modern chemical engineering invented microporous Teflon membranes.
It is brilliant, yes.
Or consider the permafrost food storage tunnels.
The subterranean natural refrigerators.
Exactly. Archaeologists have found these deeply excavated underground chambers connected to the primary winter shelters by short, subterranean tunnels. They specifically utilized the ambient temperature of the deep permafrost to keep scavenged meat frozen safely.
Which kept it away from predators, too.
Right, protecting it from both predators and the worst of the surface storms, while remaining accessible without having to go outside into the -40 wind chill. These were purely logistical, physical solutions to brutal physical problems. They are entirely valid for modern military adaptation, regardless of any surrounding social customs. A modern unit can, and does, utilize subterranean cold storage concepts in extreme Arctic deployments without needing to engage in Ice Age mythology or bone burning. The engineering logic stands completely alone.
I hear the structural logic in your argument, but have you considered what happens when the system fractures? What happens when that brilliantly engineered composite clothing tears on a branch?
Well, you repair it. Or when the permafrost tunnel inevitably begins to thaw and cave in due to a slight shift in geothermal heat. Or when the breathable vapor barrier in the wall suddenly freezes solid because the fire dipped too low for 20 minutes. The text we are referencing specifically notes that when the shelter was damaged, which was a constant reality because biological materials rapidly degrade under stress, it was repaired immediately. There was ongoing, relentless maintenance required throughout the entire winter season.
But maintenance is a universal reality of all engineering, ancient or modern. A jet engine requires maintenance. A skyscraper needs maintenance.
Yes, but let's compare the realities of that maintenance. Modern maintenance on a disaster relief tent means a soldier notices a draft, pulls out a roll of synthetic adhesive tape, slaps it over a rip in the nylon, and goes back to sleep.
Okay, true. It's easier now.
Ancient maintenance meant realizing your thermal envelope was compromised in -40-degree weather. It meant going out into that lethal environment, successfully sourcing a new hide, physically processing and chewing that hide to make it pliable, and structurally integrating it into the actively utilized wall without letting the interior freeze in the process. The resilience of the ancient system was not in the materials themselves. It was entirely dependent on the continuous, crushing physical labor and the supreme environmental mastery of the people operating it.
It was a harder life, absolutely.
And look what happened. When the Ice Age finally ended and the global climate warmed, this entire incredible knowledge system was abandoned. It wasn't lost to some grand catastrophe. It was just rendered biologically unnecessary. Modern humans look at the archaeological remains and they see a brilliant tent. They don't see the relentless, daily, exhaustive labor required to keep that tent from becoming a frozen tomb.
Despite our disagreement on the exact nature of what is being extracted today, I think we are actually circling toward a really profound synthesis here. If we look at where our perspectives perfectly align, we both agree profoundly that the popular, modern image, the primitive, shivering cave people just helplessly, stupidly enduring the cold, is not just historically inaccurate. It is deeply insulting to the sheer intellectual brilliance of our ancestors.
It is incredibly insulting. It diminishes what is arguably the greatest survival story in the entire history of our species. We owe our very biological existence today to the fact that they were not primitive, shivering victims. They were meticulous, highly observant, ingenious engineers.
Absolutely.
Every single night survived in those conditions on the steppe was a masterpiece of calculation. A single minor mistake, a poorly placed ventilation hole that caused a draft, a misjudged stockpile of dried dung fuel, a tear in the outer hide that went unnoticed at sunset, could literally mean an entire extended family frozen solid before dawn. The stakes of their engineering were absolute.
And the fact that we spent the last 100 years developing modern industrialized building science, utilizing computer models and synthetic polymers, only to turn around and rediscover that our ancestors had already solved the exact thermodynamic math perfectly with nothing but bones, hides, and stone tools, that is something that commands deep, enduring reverence.
It really is humbling.
My view remains that this proves they discovered universal thermodynamic truths. They mapped the physics of radiant heat, composite insulation, and convective ventilation so perfectly that we, with all our modern synthetic materials, literally cannot design a better geometric and thermal system for those conditions.
And, well, my view remains that while the architectural geometry is undeniably brilliant, true Paleolithic survival simply cannot be reduced to a structural blueprint you can pack in a military crate. It was a holistic symbiosis. It was proactive seasonal planning, highly engineered chemical fuel management, continuous exhaustive physical maintenance, and biological sleep rhythms, all functioning together as a single indivisible organism. Extracting the tent design without the arduous, highly adapted lifestyle that sustained it is a luxury that only modern, industrialized technology can afford.
It really forces us to take a step back and think about what other ancient, holistic systems modern technology has arrogantly forgotten or simply automated away. We tend to look at the deep past as primitive, but perhaps we have just traded profound biological and environmental integration for mechanical convenience.
We absolutely have. We traded the profound necessity of the campfire for the invisible convenience of the power grid.
Which brings us back to the most mundane object in your house right now. The source material leaves us with a truly lingering, haunting thought. How extraordinarily rare and miraculous it is for a human being to simply be warm. We want to leave you, the listener, with that exact image. If you are at home, look at your thermostat.
Yeah, just that little glowing screen on the wall.
The digital number glowing on that screen represents a continuous, perfectly stable temperature that your ancient ancestors would have considered a literal miracle. Not because they couldn't achieve it, as we've discussed, they engineered it in the most brutal, unforgiving conditions on Earth, but because achieving that warmth cost them constant, unending vigilance, exhaustive physical labor, and absolute, flawless precision.
Every single degree of warmth had to be earned with human energy.
So the next time the deep cold comes in the winter and you reach out for that thermostat without even thinking about it, you have to ask yourself, has modern technology truly surpassed our ancestors' engineering brilliance, or have we merely automated the courage and the profound labor out of the equation? Thank you for joining us.